Hello everybody and welcome to 3D Printing Basics. I just wanted to let you know that if you're interested in getting every single episode a week before its release and ad-free, then please head over to my Patreon. The link will be in the show notes, and like I said, you can get every single episode ad-free and a week before its initial release date. Thank you guys so much for listening, and I hope you like this episode. Hello and welcome back to 3D Printing Basics. This is episode number 92, and in this week's episode, we are going to be talking about how to design parts for strength without using these crazy exotic filaments like carbon fiber, filled filaments, nylon, engineering filaments like PEEK. None of that. We're going to be talking about how you can best design your parts so that you can use normal filaments, easily accessible filaments like PLA, PETG, etc., and still get really strong usable prints. And that's pretty important and simple enough. You can get a lot of strength just from your design choices and not necessarily from expensive materials. The expensive materials can definitely help if you need some really strong prints, but more often than not, you can get the strength you need from the design and from the print settings, not from the material itself. So with that being said, let's get right into today's episode. All right, so before we get started, I wanted to talk about specifically what the different kinds of strength actually mean in 3D printing, because you could be designing parts for completely different purposes. You could be looking to design parts for tensile strength, which is resistant to being pulled apart. You could be designing for compressive strength, which is pushing or squeezing on the part itself. You could be designing it for shear strength, which is making sure that it doesn't snap in half under any kind of load. Or you could be designing it for impact resistance, which could be sudden hits. If you drop it, you need it to stay together. There are different kinds of applications. Strength is not an all-encompassing word, at least in the 3D printing industry. There are different kinds of strength and different kinds of applications. So I'd say that's most important before you start designing anything at all, is to identify what the weak points you think might be and what the specific strength and the kind of resistance that you want it to have, and that's going to kind of guide your design choices as you go through making the parts. So the biggest strength factor and what I look into when I'm designing or printing any kind of part is going to be layer orientation. So when you have the layers oriented a certain way, we know when you build layers up, that's the shear point, right? In between the layers, that's where parts can snap if they're put under any load. And the opposite way that the layers are going is the stronger part or orientation of the print. So if you have, for example, a long rod, say 12 inches long that you're printing, and it's almost like a dowel pin, and you need it to not snap in half, right? Because it's going to be bent, it's going to be pushed under load on both ends. And so then you don't want to print that rod straight up and down, because the layers going up and down, going all the way up the length of the rod, those are very prone to snapping, especially if you put loads on both ends of it. But if you print the rod laying down so that the layers are going across the length of the rod rather than going up the length of it, they're going across the length of it. That is going to make the rod very strength resistant, and if you put loads on either end, it's going to hold up a lot better than if you printed the layers straight up and down. Now, granted, that comes with its own set of issues, especially if you're using a smaller diameter, because when you print something that is round that way, oftentimes, more often than not, it does not come out perfectly round, and you have some print details there. But we are just talking about strength here, and so layer orientation is going to be one of the biggest strength factors, and you want to make sure that whichever way you think the part is going to be flexed, or wherever the load is going to be, if it's going to be bent in any kind of way, you want to make sure you have the layers oriented to be the most resistant to shearing, because in 3D printing, that is going to be kind of the biggest strength inhibitor. It's going to be the biggest weakness of all your 3D printed parts, is whichever way the layers are going, those shear points, that is going to be the biggest issue when it comes to being strength resistant or being able to hold up over time. The next factor that is very important when we're talking about designing parts for strength in 3D printing is going to be geometry. Geometry will oftentimes beat material choice when it comes to the strength factor. So the first thing you want to think about is fillets over sharp corners. So I'm talking roundovers, chamfers. So sharp corners, they concentrate stress, especially if you're looking to make them drop resistant. Those corners are so small, they're going to chip off super, super easily, as usually with sharp corners on other objects, not just 3D printed objects. So fillets, roundovers, chamfers, they're going to spread the load and they're going to make it much more drop resistant and also much less prone to the edges kind of chipping off or flaking away. You're also going to want to make sure that you have thicker sections where it matters. So add material where the stress is the highest, whether you need to add more infill in that section, whether you just want to add just more kind of mass there so that there's just more material to be able to hold up. And then you can also make ribs and gussets over solid blocks because these ribs, the geometry of them, they're designed to hold up better than just a straight solid block. So those are definitely some things you can think about. Another thing to think about is that you want to avoid thin and flat plates, especially with 3D printing because they flex easily and they also snap really easily. So if you're printing something that you really need to hold up over time, and if it's just a flat plate, then honestly 3D printing might not be the avenue that you want to go through, just because no matter what material you use, it's going to flex and it's going to eventually snap. It's not going to be something that can hold up over time, but you want to add curvature if you can, and you can add ribs. You can stiffen these parts up and make them a lot more able to hold up to the stress of a working environment if you just change some of the geometry, add a little bit more material where you can, and just overall it's going to make it a lot stronger. Another thing that matters, and this is actually something that I didn't really know until recently. So when I was previously trying to make really strong parts, I always just upped the infill. I would change it to 35, 40, 50, 60% if I needed to. And I always thought that that mattered more. But what I've learned recently and what I've been experimenting with is actually increasing the wall count. And what I've found and what other people have found, this is not just my opinion, this is a generally proven opinion, that walls matter more than infill. If you add more walls, for example, the common setting for 3D printing is usually 2 walls on the outside. And if you change that to 3 to 6 walls, it becomes infinitely stronger than increasing the infill from 20% to 30%, 30% to 40%. Adding more walls will make your part overall stronger. Now, the trade-off there is that it definitely does use much more material than adding more infill does, and it's going to make the print overall take longer. So that's something to think about. If you are in a rush, you might not want to do that. But if you are simply looking for strength, adding more walls is going to do more for you than adding more infill. That is not to say that you should go 5% infill, and as long as you have 5 walls, then it's going to work out. No, you need to have them in tandem with each other. But if you are at the point where you need to add more strength and it just isn't working, add more walls because that will make it stronger than adding more infill by itself. So that is definitely something to think about. And like I said, something that I just learned recently, I always thought it was just infill, just increasing infill will make parts stronger, but the combination of the two has really helped make these strong parts that are lasting in a working and industrial environment. So that's what I love about 3D printing is I've been in the game for 5-6 years at this point, and I'm still learning new things every day. It's just why I love 3D printing and why I hope you guys do too. Another strategy to help make your print stronger is going to be the infill type that you're using. One thing that I've always disliked about Bamboo Studio is that their generic default infill pattern is grid. And the grid infill pattern is not good in my opinion, because it doesn't support on the 3 different axes. It supports the X, it supports the Y, it does not support the Z axis. And so I always find myself changing it to cubic. Cubic is my number one. It's the infill that I use on every single part, no matter what is going on. I use cubic, and sometimes I use adaptive cubic, which is the same exact thing. It's just saves filament here and there. But cubic overall is my favorite. It supports on all 3 different axes, all 3 dimensions, and it still prints things really well. And overall, it is pretty filament efficient. Grid is definitely going to be the most filament efficient, but you're trading off the strength there. So if you are printing parts for strength, make sure that you check your infill pattern and either use gyroid or cubic. It's the 2 most common ones. I don't like gyroid because of the way it kind of swings the printer back and forth. It seems like you could have issues there if your input shaping is off a little bit, or it seems more stressful on the printer overall than just going with cubic and its straight lines. But overall, your infill pattern is going to be very important. Don't use grid if you need something that is going to be super strong, because like I said, grid only supports the part in 2 dimensions and not all 3 dimensions. The last one that I'm going to mention is going to be about layer height and line width. So if you have thicker layers on your printing, so the standard is usually 0.2 millimeters. If you go ahead and say use 0.28 millimeters, 0.32 millimeters, then you're going to have better layer bonding, which is something that I didn't think that. I always thought the higher layer heights meant less layer bonding, but the thicker layers, because you're extruding more material, more of it bonds to the previous layer, so then you have the better layer bonding. And also, if you use wider extrusion lines, then that's exactly, it follows the same pattern as the thicker walls, as the thicker layers, because you have more material being extruded at once, so more of it bonds to the previous layer, which in turn creates better layer bonding. So if you are printing something and you really need good strength, think about maybe switching from a 0.4 millimeter nozzle, which is the default, to maybe a 0.6 millimeter nozzle, and therefore you can get up to a 0.32 millimeter layer height, which improves durability. And then you can also use the 0.6 millimeter nozzle to have the wider extrusion lines, which extrudes more filament, which comes into more contact with the previous layer, ensuring a better layer bonding. And that is definitely really important. You want to make sure that if you are designing parts for strength, that you have really good layer bonding, because you want it all to come out as one solid piece. If you have any issues where layer bonding is not super good, then when the part is put under stress, it's going to keep separating until it eventually just shears off. And with that being said, that's kind of all I had for you guys today. I really hope that you guys enjoyed this episode and learned a lot about how to design prints for strength, and how you don't just need these high price point engineering filaments. If you design parts to be strong, then it doesn't matter what you're using, what material you're using. You will have strong prints. So I hope you guys learned something from the tips. If you guys have any other tips for creating strong prints, then go ahead and drop them in the comments down below. Thank you guys so much for listening. This will be the last episode of 2025. Or actually, sorry, this is the first episode of 2026. I got my dates mixed up. So thank you guys so much for listening, and here's to another great year of 3D printing basics. So thank you guys for listening, and I'll talk to you next time.